Today we'll discuss the Raspberry Pi software, the Linux operating system in particular. An embedded system is a device with a microprocessor engineered for a particular purpose. To achieve that, the device needs an operating system that is robust and fast. That is why embedded systems do not use general purpose operating systems, but instead use systems that are designed specifically for the embedded system. An embedded system operating system is an operating system designed and optimized to improve the efficiency of managing the hardware resources and to reduce the response times specifically for the task the device was created for. Some examples of embedded systems are industrial robots, Internet of Things devices, smartphones, smartwatches, drones, medical devices, video game consoles, and many more. Now, the Raspian OS is derived from the Debian OS, and it's released specifically for the Raspberry Pi. Now, as of this date, the Raspbian version is Raspbian GNU Linux 10, or the Buster version. Issuing the command uname-a will return the Linux version from the Linux command line. Performing a systems upgrade is going to be your first systems maintenance task. Connecting the network. Regular Ethernet. Regular Ethernet connects to a switch or a wireless router just like your personal computer does. It's relatively easy if you have control of your network because you understand the configuration, you have access to the router and switches. More complex networks, such as the networks found here at the university or in larger corporate settings, will be more difficult or impossible to connect to the particular device, the Raspberry Pi, as it comes out of the box, to just a regular LAN, Ethernet LAN, a corporate LAN, or university LAN. Now, you'll find that the network scanning software to be useful to find your Pi when you're attaching it to an Ethernet LAN. So Nmap or ZenMap, which is the GUI version, is the recommended piece of software, a network scanning software. And what you'll be looking for is an open port 22 and a Raspberry Pi Foundation MAC address. Okay. Now, the Ethernet crossover cable is another method of connecting to the network. And any cable will work with the Raspberry Pi Model 4 because it has auto-sensing RJ45 Ethernet connection. So traditionally, a crossover cable was required to connect two computers directly together. Modern computers are all auto-sensing, so that requirement is not as stringent as it used to be. Now, using the crossover cable, what you're going to do is you're going to connect your Raspberry Pi directly to a computer, the computer you'll be using to control the Raspberry Pi. Well, could be. And you can use either a bridge method or an internet connection sharing method to provide internet connectivity to the Raspberry Pi. In the bridge method, the Raspberry Pi pulls its DHCP address from the local area network. And you can use your PC's command line tools to help find the Raspberry Pi IP address. Or you can use network scanning software. Now, to properly shut down the Raspberry Pi, when you're first connecting with the bridge method, it requires that you either have the USB to TTL cable, which you don't have, or you have a mouse and video display. And the reason for that is you cannot create the bridge connection unless the Ethernet port is enabled. And to enable the Ethernet port, it's got to be connected, right, and the light's on. And so that means the Pi has to be on and connected to enable the Ethernet port on the PC. The Pi will not draw its DHCP address in that state. By the time you get the bridge created, the Pi is beyond the state that it would draw its DHCP address, and so the Pi sits there in its unconfigured form. So to get the Pi, after you create the bridge, to get the Pi to pull a DHCP address off the LAN, you have to reboot the Pi. But as you can see, you don't have vision into the Pi to boot it. You don't have the little push button to reset it. You don't have the USB to TTL cable. So you got to have the mouse video display so you can get to the GUI and click on the icon and shut it down. Now, you don't have that problem if you use the internet connection sharing method. You're isolated from the LAN to begin with. I kind of like that. You can't get to your Raspberry Pi from anywhere but that PC that's directly connected to it, which gives you a little security and perhaps keeps some accidents from happening. You're isolated from the LAN. The internet connectivity, you achieve internet connectivity by pulling a DHCP address from the local host, not from the LAN. And that'll be a different DHCP address. And you can only access that DHCP address from that local host. That's why it's isolated. And you can use, when you use that method, you can use a fully qualified domain name to connect. raspberrypi.mshome.net if you do this over a Windows computer. Now, communication. Once you have a network connection, how are you going to talk? How are we going to talk to our Raspberry Pi? So we're going to connect via secure shell, SSH, using a software utility called PuTTY. You see on your screen the link to download PuTTY, and another way to gain access to your Raspberry Pi is by writing a process, or your embedded system, really, is to, and it's the way most embedded systems once you get outside of network control devices like switches, routers, things of that nature, when you get to consumer level devices like smartwatches, beaconing will be a method that enables you to find the device and connect to it. And by beaconing, I mean a beacon is a remote process that phones home. And this method allows access through stateful firewalls and is a good way to connect to internet-connected remote devices when you have no idea what the IP address is going to end up being. So when the device fires up, you hook it to the LAN, hook it to the WAN, configure it through some type of interface, Bluetooth connection off your smartphone, or however you're actually able to get in and configure your smart device. That smart device will call home. And a stateful firewall means that it remembers I went out and asked for something from that port and that address. And when that address and port answers back, that's allowed back through. It's stateful. And so if you have a device that's beaconing, it's allowed through, and the return traffic is also allowed through. And that's a convenient and common way to access your remote embedded device. Now, upgrading the Raspberry Pi software. That's the first thing we're going to do, really, when we get our hands on our Pis. So we're going to connect to it. We're going to communicate with it. And once we've established communications with our Pi, we're going to update the operating system so that we all have the latest and greatest version. Now, when you start this, make sure you have time, because it can take hours depending on how old your current image is and how fast your internet connection speed. Older images will require more updating, therefore there's more packages to download and more things to install. A call to the application packaging tool, or the APT, the call to APT update loads the latest package list from the internet. Then a call to APT upgrade will download and install the new application packages that are on that list. Now, these are privilege calls requiring root authority, and so the syntax would be sudo apt update, sudo apt upgrade. And to install a new app, you would call the apt install, which is sudo apt install xrdp. Now, at the end of this chapter, what you'll be responsible for on the test is how to connect via Ethernet, how to communicate with PuTTY, how to manage Linux packages, and how to safely shut down and reboot the Pi.